Dear students, today we are going to start with introduction to logic gates in our subject digital electronics. First of all, what is logic gates? As we know, the gate is nothing but is something to we can pass. So in this way, like it is also the building block which is used to create a digital circuits. There are basic three gates: AND gate, OR gate, and the NOT gate. These are the simple three gates, and we can derive some another gates with the help of these three gates. Every gate or every logic gate is having its original logic symbol and its truth table and its boolean notation. So start with our first logic gate, then I will explain one by one. So what is logic symbol, what is truth table, and what is the logical expression. So first gate is AND gate. The AND gate is which has a circuit symbol as shown in the figure A, which has two inputs, that A in and B, and which has one output, that is C. So truth table of AND gate is shown in the figure B, where A and B are the inputs and C is the output. So first of all, what is truth table? Truth table is the mapping of inputs with their outputs. So left hand side we have all the inputs. It may be one input, it may be two input, it may be three input. AND gate can be three input also, and output is only one, that is C. So how to write this truth table? Look at the truth table figure B. Is this in this A and B we are taking the variables. How different variables can there be of A and B? These are the four variables, like 0 0. A might be 0 at that time, B will be 0 at that time. What will be the output that will be shown in the column C? Okay, so this is how we write the truth table. So this notation, there is a trick to write A B and A B, that is these variations is like read like 0 0 0 1 1 0 and 1 1. So this variation, this is common for all the truth table, only the C is changing in every gate. Okay, so we have to write like 0 0 0 1 1 0 1 1. You can treat it like 0 is nothing but off and 1 is nothing but on. So here this AND gate, its logical expression is shown in the figure C, that is C is equal to A and B. So A and B means you can take it as A into B, like this is the multiplication we use whenever you want a multiplication. So you can go for this gate, like now you have to use this Boolean expression in your truth table, like C is equal to A into B. So put the value of first is A is 0 and B is 0. So what will be the C in truth table? So now look at the truth table. When A is 0, B is 0. Multiply at this point 0 into 0. The C will be 0. Next, sorry. Next, again A is 0, B is 1. 0 into 1, C is 0. Third, 1 into 0, anything into 0 is 0. That is again third condition is also 0. And last condition, when A is 1 and B is 1, at that time C is equal to 1. That is 1 into 1 or 1 and 1 is equal to 1. So this AND gate is nothing but when both the inputs are 1 or both the inputs are high or when both the inputs are on, at that time output is 1, else output is 0. Here you can consider it as when both the inputs are true, at that time output is true, otherwise output is 0. Now applications is security. So application of AND gate is nothing but we can use it in the security system. For example, if you are going out from your home and you have to set an burglar alarm. So burglar alarm is the most common example of an AND gate or the logic gates mostly used. So burglar alarm, in which when you are going out, at that time when you set the alarm, so it will set the alarm where it will set the first switch to the one. When a third person or when a theft come inside your house, or when a robber comes inside your house, at that time, with the help of a person detector sensor, a person detector or sensors, with the help of that, that will again set to 1. So your switch, first switch is already 1, that is high, and when the person come inside your house, so that will again turn with the help of percentage, that will also again become 1. So 1 and the 1 at that time and operation does there, and that will set your alarm, and your burglar alarm will start ringing. That is 1 into 1 or 1 and 1, that will give you 1, and your alarm starts ringing. So this is the popular example of an AND gate, that is the burglar alarm. Now start with our second gate, is the OR gate. OR gate, its circuit symbol is as shown in the figure A, which has a two inputs A and B and the output C. Second is here the truth table for the OR gate. In the truth table, it again I have told you the first previously that we map the inputs with the outputs, that is called as a truth table. So left hand side all the inputs, here we are using a two input AND gate, so inputs are A and B, we are mapped here like with the situations are 0 0 0 1 1 0 and 1 1. Now see the logic expression or the boolean expression for the OR gate. So what, for which operation we can use OR gate is nothing but C is equal to A plus B. So C is equal to A plus B means we can use here an addition, as that in AND gate we go for the multiplication. Now whenever you want an addition, you go for the OR gate. So just put the values in logic expression or boolean expression and find out the values of C as with the help of in truth table. Now put the values like C is equal to, first is 0 plus 0, so C will be 0. Next is 0 plus 1, C will be 1. Next is 1, A will be 1 and B will be 0. At that time C will be 1 plus 0, 1. And last condition, 1 plus 1 is again 1. Don't consider here as 1 plus 1 is 2. This is we are dealing with the we are not dealing with the algebraic addition. This is a logical addition, or this is a binary addition. So here is 1 plus 1 is 1 0, where 1 is a sum and 0 is a cal. Okay, but don't write here 1 plus 1 as a 2. So what you have to write is, first remember the column C is when 0 and 0, that 0 plus 0 is 0, else in other condition whenever one of the input is high or one of the input is 1, output will be 1. It is exactly reverse of an AND gate. Okay, so here you can write when two or more inputs are low, at that time output is low, else output is high. Okay, or you can write when when both the inputs are 0, at that time output is 0, else output is 1. Or you can also say when both the inputs are off, at that time output may be off, else output is on. Okay, next is your third gate is a NOT gate. NOT gate is the simplest possible gate, is called as an inverter or NOT gate. It is used for an inverting operation. When the circuit symbol of a NOT gate is shown in the figure, it has only one input and its output is B. As A is input, output is B. The symbol shows a triangle and bubble in front of that. That bubble in front of that shows it is doing an inverting operation. Inverting means if you are giving it a 0, it will give you output as 1. If you are setting an input to 1, the output will be 0. Now look at the boolean expression. Figure C at C is B is equal to A complement or A bar. So B is equal to A bar means when A is 0, output is, look at the truth table, when A is 0, B equal to 1, when A is 1, B equal to 0. So this is how you get the truth table from the Boolean expression. One bit as an input produces its opposite as an output in the NOT gate. Okay, so you got, these are the three basic gates we have studied. First, AND gate, second, OR gate, and third is a